Hello students, welcome to Extreme Telugu. Today's topic is 10th class physics, lesson number 1, reflection of light at curved surfaces. In this topic, we are going to be seeing how to find the image distance or focal length using an activity for a concave mirror. For a concave mirror, the focal length is to be measured means we need to know two things, that is nothing but object distance and image distance. Why? Because we know that mirror formula is 1 by f is equal to 1 by u plus 1 by v, or 1 by v plus 1 by u. That means to find the focal length, we require the object distance u and the image distance v. Or to find the image distance v, we require focal length f and object distance u. That means we can find the image distance v or focal length f using this formula when remaining two lengths are known to us. And to know these remaining two lengths, let us do an activity which is given on this board to you. Here in this activity, we have taken a concave mirror. If we want to know the focal length, then we would be measuring the image distance and object distance. Or else, if we want to measure the image distance, then we must know the focal length. First, let us have a situation where we are required to find the focal length. Our aim here in this activity is to determine the focal length. So, I have taken a concave mirror whose focal length is to be determined, and I have kept it on a V stand. And in front of this, I have kept an object, say a candle, which is also kept on a stand, so that the height is compatible with the height of the mirror. And between these two, that is nothing but mirror and object, I have placed one screen which is mounted on a stand. So here three stands are there. One is V stand upon which mirror is kept, and on next two stands we have kept screen and object respectively, and this entire arrangement is kept along with a meter scale, and this entire arrangement can be assumed to be kept on a table or any flat surface. Now, at the zero reading of meter scale, we are keeping the concave mirror, and at an arbitrary distance from the concave mirror, say 60 centimeters or 90 centimeters or 70 centimeters, whatever may be the distance at which you want to keep the object, you can keep the object, no problem. Now, the object distance becomes 60 centimeters. Why? Because object distance is defined as the distance between pole and object. Here pole is kept at 0 centimeters, object is kept at 60 centimeters. Between 0 and 60 centimeters, the distance present is nothing but 60 centimeters. So here u becomes 60 centimeters and it is to be considered minus. Why? Because according to sign conventions, the distances that are measured in the opposite direction of the light are considered to be negative. Now, here I have kept a screen the screen is to be moved backward or the screen is to be moved towards the mirror or away from the mirror, till you get the sharp and bright image on the screen. Either you can move it towards the mirror or away from the mirror. That means to and fro you can move the screen so as to get the sharp and bright image. Once you get the sharp and bright image, stop moving this screen. Now measure the distance between mirror and the screen. Say the object image is obtained at 30 centimeters. Brightest image is obtained at 30 centimeters. Then here we have V is equal to minus 30 centimeters. Why? Why? Because the light is traveling from candle to the mirror and the distances are measured from mirror to the image and mirror to the candle, that is opposite side. In opposite side we have measured the distances, so the distances are considered to be negative here. Now by this activity we obtained u and v. Substituting these values of u and v in this formula we can obtain f, that is nothing but focal length. You can repeat this activity for 3 times or 5 times and you can fill this table. We have got object distance, image distance, and using this object distance and image distance put in this formula you can calculate focal length. For various object distances you can repeat this experiment and you can find focal length. If you know the focal length and by knowing object distance you can easily calculate the image distance. So we can calculate the image distance or focal length using this activity. I repeat in brief. We have taken a concave mirror and we have put it on a V stand, and then in front of concave mirror we have put an object, say candle, on a stand so as to have the compatibility of the heights. In between these two we have kept a screen along with the meter scale, and this entire arrangement is kept on a table. Now the V stand is kept exactly at 0 reading. Say at 60 centimeters we have kept the object, that is candle. Now in between the screen is there. We have moved the screen to and fro so as to get the sharpest and brightest image. As soon as we got the sharpest and brightest image, we have stopped moving the screen. Now measure the distance between pole and screen. This is image distance. Why? Because image is obtained on screen. As we know u object distance, v image distance, put them in this formula, you can calculate the focal length f. Hope you understood this video. If you like this video, please subscribe our channel Extreme Telugu. Thank you.